In previous sections, we saw how the user can freeze constants in the program in order to turn otherwise ambiguous updates into simple ones. Now we'll see other ways in which Sketch and Sketch can deal with ambiguous updates. Let's pick up with the n boxes example from before, but for fun, let's switch the boxes to circles instead. The little programming language comes with library functions that can draw any of the primitives in the SVG format. The arguments to the circle function include the x and y coordinates of the center, as well as the radius. We'll remove and change variables in order to match this new use case. By toggling the Zones button, we see that each circle has an interior zone and an edge zone for its border. When dragging the interior of any circle, there is the same ambiguity as before, should x0 or sep be changed. Sketch and Sketch offers simple heuristics for automatically resolving ambiguities. One approach that Sketch and Sketch takes is to resolve ambiguities by arbitrarily deciding which constants to change, while at the same time trying to be fair to each constant in the program. When hovering over the first circle, notice that x0 is highlighted yellow, and the caption at the bottom says that x0 will be updated if this zone is manipulated. That's because x0 is the only value that affects the x position of the first circle. When hovering over the second circle, the caption says that sep will change. Notice that x0 is highlighted in gray to indicate that it was considered but not selected. The yellow highlight signifies that sep was chosen instead. This choice is the result of trying to be fair, because x0 was already assigned to a zone of the previous shape. Next, when hovering over the third circle, notice that x0 is chosen. Because both x0 and sep have been assigned the same number of times, in other words, they've been treated fairly, the choice for the third circle is arbitrary, and x0 is chosen. For the fourth circle, sep is chosen to restore fairness. If we change the number of circles, we see that this alternation between x0 and sep continues. So, Sketch and Sketch breaks ambiguities arbitrarily, but tries to do so in a way that no constant in the program wins overly often. Note that these decisions are made before any direct manipulation. The benefit of relying on heuristics is that we get interactivity, but the downside is that the automatic choices may not always be what we want. We must try manipulating shapes to see what happens. When the update is what we want, that's great. If not, we can either undo the action, try manipulating a different zone, freeze constants in order to break the ambiguities, or modify the source program directly. Let's see an example where the fairness heuristic is not ideal. Let's add extra variables called a, b, and c, and use them to compute the initial position x0. In this example, the values of a, b, and c are all 0, so clearly this is a silly change to the program. But the idea is that, in a more complicated design, additional expressions may affect the computation of this x0 value. For every circle except the first, there are now 4 options to consider: the values of sep, a, b, and c. Based on the fairness heuristic, each of these variables will get chosen every 4th time. But because a, b, and c have no real effect on x0, it's as if x0 is being chosen 3 out of every 4 times. Though fair in terms of how often each particular number in the source code is chosen, Sketch and Sketch has favored numbers that affect multiple expressions later in the program. Because any one simple heuristic is not ideal for all situations, Sketch and Sketch offers another way to automatically break ambiguities, namely by taking into account the degree to which a number in the program affects attributes in the output. For example, during program evaluation, the sep value is used n-1 times when computing the x attribute of each circle except the first. The a value, on the other hand, is used 2n times, twice for each circle. Similarly, b and c are also used 2n times each. If we toggle the heuristics button to biased mode, Sketch and Sketch will favor numbers that affect a fewer number of attributes in the overall design. Hovering over the first circle, we see that any one of a, b, and c could have been chosen. Because all three were used just as often during the execution of the program, A is arbitrarily chosen. For the second circle, SEP is chosen because it was used less often during program execution than A, B, and C were. For the same reason, SEP is chosen for all remaining circles. This heuristic does not try to balance the number of times each constant is assigned to a zone. In the rest of our examples, we won't distinguish between the different heuristics. The main takeaway is that simple heuristics can help by providing interactivity in exchange for precise control over the results of direct manipulation. Later on, we'll look more closely at examples where these heuristics may or may not work well. If we would rather not have ambiguities resolved using heuristics, we can toggle the heuristics button to none, in which case Sketch and Sketch will attempt to resolve only simple updates, not ambiguous ones. In this section, we describe two modes in which Sketch and Sketch automatically deals with ambiguities. In the first mode, Sketch and Sketch tries to be fair to each constant by trying to balance the number of times any constant is assigned to a direct manipulation zone. In the second mode, Sketch and Sketch is biased towards program constants that are used relatively infrequently in computing attributes of the output design.